Okay, in this segment, hopefully I have enough memory on my iPad, so I'm going to talk really fast. I filled in a couple more on the chart. I filled in C3H8 to show that I could do 1, 2, 3 in a longest chain, or 1, 2 and make a branch, which is still 1, 2, 3. That is the same as that, and that's the only structure you can make for C3H8. And by the way, we would call that propane. Okay? Propane. Okay? All right, and then over here, C4H10, we have butane, 4 in the longest continuous carbon chain. Now we have 3 and a branch. So this is an isomer of butane. All right, now as far as naming, okay, I think we got that. 2-methylbutane, 3-ethylpentane. Let's name this 2-methylpropane. Okay, now I'm going to bring you over to your book. Your book starts drawing structures as zigzags. And that is because of the Vesper. If you guys remember doing Vesper, we had that tetrahedron where we had the 109 degrees. You often see these as zigzags. Same thing like this. Okay? And what you end up seeing is a line drawing. A line drawing where each time that I change the pen, whoops, I got one too many in there. Each time I change direction of my pen, I have a carbon. Okay, so that's going to lead me over to what happens when we get something that's cyclic, like this. Okay, so I can take my pennies, and I can take my 5 pennies. That would be pentane. Okay, so this would be pentane, and I can put it in a circle like that. Okay, 1, 2, 3, 4, 5. Or I could draw it as a line drawing. Okay, so you're going to name it the same way. You just say cyclo and then the 5 carbons. Pentane. Okay, cyclic structures are very, very, very common. Okay, so I can have 6, 3, 4, 5, 6. There's my hexane. Or I can put it into a cyclic structure like that. 1, 2, 3, 4, 5, 6. My line drawing. As I change direction of my pen, carbon, 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 carbon. Cyclohexane. I can take 4. Here's my 4. Put it in a structure that's cyclic. 1, 2, 3, 4. So it's kind of like geometry. Cyclobutane. 3 carbons. Cyclopentane. And we can put branches on this, and we can talk about this for weeks and weeks and weeks, which is actually what you would do in a regular organic class. Okay? Practice. All right. What happens when we lose hydrogens? Okay, so if we go back to our notes, we lost 2 hydrogens, we made a double bond. Well, now we've created something that is a little different because we don't have the same formula. So now instead of CN2H2N plus 2, we've lost 2. So CnH2n plus 2, we've lost those 2. And those are no longer alkanes, those are called alkenes. Naming is the same, except instead of ANE, we get ENE. Okay, and the carbon-carbon double bond gets the priority. All right, now carbon-carbon bonds are no longer free to rotate. We get what we call cis-trans isomers, but we're just going to skip that for the purposes of this lesson. Okay, so if I have this structure, I would name that